Welcome to 9.1. We're talking balanced equations with addition subtraction. We're going to talk about how addition and subtraction interact together, as well as what an equation is and how we understand the concept of balancing. To review a little bit, we're going to talk algebraic expressions, which is from Unit 8. Algebraic expressions are mathematical combinations of constants and variables combined using operations like addition, subtraction, multiplication, division to represent a value. We have some examples down here below of algebraic expressions. 3x minus 5, 6y minus 8x plus 2, 3x squared plus x minus 2. Individual terms make up the algebraic expressions. They are separated by addition and subtraction. A term is a constant, variable, or a product of both. So for example, we look down at our examples of algebraic expressions. We have 3x minus 5. 3x is a product of a constant, 3, which has now become a coefficient of 3, times a variable, x. Negative 5 is a constant. We have two terms. 6y is a product. Negative 8x, positive 2. We have three terms. Again, three terms. Then we move on to equations. Up to this point, we have not used equal signs in any of our math work. An equation is a statement that two algebraic expressions are equal to each other. If we look at the word equation and the word equal, we see that the important part of an equation, what puts it apart from an algebraic expression or anything else we've done in algebra so far, is that there's an equal sign involved. A linear equation, which means an equation that could define a line, can only have one solution. These are the types of equations we'll be looking at in this unit. The variable can only equal one value. So we're going to start with these variables being unknown. By the end, we're going to know what they equal. When we look at an equation, we think of it as a scale. It has to remain balanced. Whatever's on one side of the equation has the same value as the other side of the equation. Let's start small. Let's talk about just shapes. On the left side of this equation, I have two triangles. On the right side, I have three circles. If I wanted to balance it out and make sure I had the same amount, I would have to imagine there are three circles on the left and two triangles on the right. Now we have a completely balanced equation. Likewise, here I have three circles on the left, one triangle on the right, two triangles, two circles. So I need to think, what can I do to balance? I could add one triangle here. I could add one circle here. Now I have the same amount of triangles and circles to keep things balanced. On your own, just to get the concept of keeping an equation balanced, whether it's shapes in this case, or constants, or variables, or terms. On your own, try 1 and 2, pause the video, and come back when you're done. Welcome back. So you could have gone ahead and added one triangle here, three circles. We have three circles here, so I want to make sure I have three circles here. Here I have 5 triangles. Here I only have 2, so I want to make sure I have 3 more. Now, we have not yet solved an equation. We've just looked at balancing. What can I move around? What needs to go on which side to equal out the other? Let's look at 8x plus 2 and 8x. Well, we have a plus 2 on the left side, but not a plus 2 on the right side. I could add plus 2. That would balance things out. Likewise, I could also subtract from this side a negative 2. Either way, we would balance the equation. This would give me 8x and 8x. If I added 2, it would give me 8x plus 2 and 8x plus 2. I could do the same over here. Now I have 9x, 7x. Just like our diamond, our triangles, and our circles, we have a combination of constants, or now coefficients, because I'm multiplying them by a variable, and my variables, I also have constants. 9x's, 7x's. Well, I could add 2x's to balance it out. Or if I wanted to balance out my x's, I could also subtract 2x's from the left side. From the right side, I have 5 and 8, I could subtract 3. Or on this side, I could add 3. We're starting to see the connection. We're doing the exact same values in both cases. We're using opposite sign. Minus or negative 2x, positive 2x, positive 3, negative 3. On your own, try to balance out these four using either addition or subtraction. As we've seen, you can do it with either. Pause the video and come back when you're ready. Welcome back. I have 10y on the left, 5y on the right. Now to make 10y over here, I could add 5y, or likewise, I could subtract 5y from this side to equal it out. We're trying to balance. Same value, just opposites. Negative, positive. 10 minus 2x. Here I just have negative 2x, so I could add my 10 here. That would give me 10 minus 2x. Or I could add 2x, which would cancel out my negative 2x. Oops. Wouldn't want to do that. Let's make a correction here. Sorry, guys. We're going to subtract that 10, so we see that we're getting same values, but opposites. 9x minus 8, 5x minus 5. I could add 4x to the right to balance out my 9's, or 9x, I should say. Or I could subtract 3 to balance out negative 8 and negative 8. Or I could add 3 to give me negative 5. Or I could subtract 4x to give me 5x. We're using the same values, but we're using their opposites. One is negative, one is positive. We're trying to see that addition and subtraction can have very similar effects when we're causing an equation to balance itself. Now, 12x minus 9x, remember back to combining like terms. I'm going to change something real quick. You can make that into 3x. So, I'm balancing 3x with 21x plus 2. I could, on this side, add 18x to make it 21x. And then add 2 as well. Likewise, I could take 21x minus 18x to give me 3x and subtract the 2. We are seeing opposites happening. Same digits. 5y, 5y, negative 5y, positive 5y, 10, 10, negative 10, positive 10, or minus 10, adding 10. Same concepts, just opposites. On your own, think, reflect on what we just saw about the connection between addition and subtraction. Then, in your own words, think about what the word solving means. We'll discuss these terms in class. Pause the video and come back when you're ready. Alright, in algebra, solving means to find the value of a variable. We're trying to find what that unknown represents. We're making the unknown known. Let's look at balancing again. When we had 5 and 7, we could have either subtracted 2 to make 5 or added 2 to make 7. Let's put something in that place, a placeholder, a variable. If I had 5 plus x, well, I have 5 and I have 7. I need to balance out the 5 and the 7. I could add 2 to 5, which would make 7. So x has to equal 2. This mental method is probably the easiest and earliest way to solve an equation. And you've probably done this before when you first learned addition and subtraction. You may not have seen the variables before, though. For example, 12 plus what equals 14? I just need to fill that gap. We're going to talk tomorrow in class about why this really works, why this method works for you in your head. Now, this isn't going to work for all the problems. This is just to understand how equations work, how variables work. It has to be 2. 12 plus 2 equals 14. I'm trying to make a true statement. 25 minus something. 25 minus question mark equals 15. Well, 25 minus what? 25 minus 10 makes 15. We may know this fact in our heads, what we call a fact family. We'll talk about those in class tomorrow. On your own, try these 4 problems, pause the video, and come back when you're ready to answer. Welcome back. Answer to number 1, you should get 15. 30 plus 15 equals 45. 20 minus 1 equals 19. 40 plus, and this one would have been trouble. And this is the type of problem where tomorrow's lesson will make a lot more sense. But those of us that understand negatives pretty well would know that 40 plus negative 20 would give us positive 20. 138 plus what equals 138? Well, 138 plus 0 equals 138. To get the same value on both sides, I didn't need to do anything to balance it, so I can add 0. We just talked one-step equations involving addition, subtraction. Real quick, on a scale of 1 to 5, rate how well we hit our learning target. Thanks for coming by, and I'll see you in class.